Kia ora tātou katoa. Morning, everyone. My name's Michael Steedman, Deputy Pro-Vice Chancellor Māori at the University of Auckland, Waipapa Taumatarau. Shortly, I'll be offering some words of welcome, mihi mihi, particularly poignant at the beginning of Wiki o Te Reo Māori, or Māori Language Week here in Aotearoa. Nā reira, e mihi ana ki a koutou katoa, māku tīmata ki tēnei mihi mihi ki a tātou, nā reira kia ino i tātou. Tikina tikina atu rā te pūtake o ngā kōrero, tikina atu rā te hautapo o ngā ariki. Kai whatatia tāne te wānanga ki runga ki nei ruanuku, kia koe te matapunenga, mai angi te matapu iho iho kia haka mauai kia tīna, haumi e hui e, tāki e. He ha te hau e wawara mai e wawara mai. He tiu he raki, he tiu he raki. Nāna ia mai te puputara ki he kiota. E tikina atu e au te kōtu koi te pauwhakairo ka tū ki te waitamata. Yoku wairangi, te he wā mauri ora. Yaku nui, yaku rahi, e ngā pūkenga, ki ngā mātanga, puta no te motu, te ao nei hoki. Haramai, haramai, haramai. Haramai roti te karanga o tēnei kaupapa tātou, tō tātou hui nui. I roti nā tini kaupapa pikai hia i roto i tō koutou pukahiwi haramai. Haramai i roti te karanga hoki, nisi, koutou katoa, e whakatū tēnei hui ko tātou. Whakatau hoki i roti te karanga o tēnei wānanga, Waipapa Taumatarau. Ngā Ngāti whātua o rāka e mihi ana, e mihi ana, e mihi ana. Tuatahi, me whakapono, tukuna mihi ki ngā whakapono, wainganui a tātou. Koutou katoa, huri ki tā atua, tēnā koutou. Huri anō ki ngā mate, huhua te wā, puta no te motu ki ngā kokonga o ngā manoa, e ngā mata katoa haere atu rā. Roti tērā ki te kuini, hi rapati, tō wehenga ki te pō, waiho, kia rātou katoa, nā whānau e pani ana, e tangi ana ki a koe, e Queen Elizabeth, haere, haere, haere atu rā. Rātou kia rātou, noho pūmau ki te atua tātou kia tātou, ka rau i ke mai nei roti te kaupapa, tēnā koutou, tēnā koutou, tēnā koutou katoa. Ka huri ki tērā o ngā reo, haka mahara mai tātou katoa. Good morning, everyone. Privileged again to offer these words of welcome in the tradition on the Māori people, in particular here at Waipapa Taumatarau, the University of Auckland, and on behalf of Ngāti Whātua Ōrākei as well. It's my privilege to offer these words. So briefly, by way of explanation, I opened with a saying, he ha te hau, which talks about the arrival of special things upon the north wind. And we offer this saying typically to visitors. So it's my privilege again to offer the words of my ancestors to you all as we gather here for this particular conference. I acknowledge the many faiths that are gathered amongst us. And I acknowledge also your ancestors. When we go through a mihi mihi or a process like this where we're welcoming people, we acknowledge not just you, but your families and those that have passed on that you hold dear to you as well. And within that, a special acknowledgement of the Queen, Queen Elizabeth, and her family that are bereft at this point in the mourning happening in the United Kingdom and across the world as well. And we acknowledge all mate, all those that have passed on at this time. And lastly, just to acknowledge everyone here, all of our expertise, all of those that hold dear the idea of developing these platforms and the use of software for those of us, end users in particular, and that's the perspective that I'm taking, that will receive these gifts from you, that receive the outcomes of your expertise, and just to acknowledge all of you again for the conference ahead and all of the fruitful discussions, hopefully, that will ensue. Nā reira, ka nawhi tēnā moku, that's enough from me. Mihi ana kia koutou katoa, tēnā koutou, tēnā koutou, tēnā koutou katoa. And it's typical in these parts also that we sing a song after we speak. So anyone that's presenting at the conference, feel free to sing a song to embellish your kōrero or your speech or the things that you've presented. So this song is a lament. It talks about a young girl waiting for her father to return home from fishing. Papaki mai, ngā ngaru nui nui, wawara tia, ngā tairere, e ripo e, ngā ngaru nui nui, te rehudai, hei ko nei rā. Kia ora tātou katoa. I'll hand over now to Nori. Nā reira, e mihi ana.
Ngā mihi, Michael. Thank you for that heartfelt welcome. Kia ora kato, ngā mihi e hoa mahi, ko nuria toku ingoa. Welcome everybody to the New Zealand Research Software Engineers Conference 2022. My name is Nuria. I co-chaired the RSC Australia New Zealand Steering Committee and am Research Communities Advisor at NESI. I have just been told this morning that we have 66 people registered and attending this event as of this morning. So welcome and thank you for taking the time to be here. We have done our best to ensure this virtual conference runs smoothly, but if there are hiccups, I want to thank you all for your patience in advance and encourage you to check your notifications on your portal regularly, where we will post updates in case of any technical issues or changes to the program. We have a code of conduct in place, which basically says, please be respectful and nice to everyone, and in the hopes that we avoid any disruptions during the course of other people's presentations. You can read about this in detail on the conference website. We expect all attendees and speakers to abide by the code of conduct so we all feel welcome and supported here. So this year, the conference theme is Sustainability, Communities, Digital Practices and Tools, which means we will be using our time together over the next 2 days to discuss what it takes to create sustainable software, digital tools and practices used to do so, and creating sustainable communities. Now, if you have not had a look at the program already, you can find what's on by scrolling through the timeline in the Events Air portal or by visiting the conference website. Thank you to all the presenters for taking the time to be here and to actively participate in our program, especially our 2 keynote speakers, Dr. Aleksandra Pawlik and Dr. Daniel Katz. You can hear Aleksandra's presentation just after this at 10 a.m. New Zealand Standard Time, where she will talk about fair research software. And you will be able to hear Dan's keynote, where he will talk to us about sustaining research software, some issues and actions surrounding it. Tomorrow at 9:30 a.m. at New Zealand Standard Time. Both are not to be missed. Before I cover some last-minute portal tips, we want to acknowledge that there was a plan to have an in-person meetup as part of this conference, but due to a lower number of registrations at each location, the organizing committee has decided to cancel them this year. We hope to run an in-person conference or component of the conference next year, and would like to understand the community's appetite for this via the post-conference survey. So be sure to look out for that in your inbox and let us know what your preference around that is. Nonetheless, if you will still have opportunities to network via the online portal later today, which we hope you will be able to make use of. If you want to chat with someone specific, perhaps a presenter after their talk, please go to the meeting hub, which is located on the right-hand side of your screen if you're looking at your timeline. And keep an eye on notifications in case someone else is trying to reach you. Finally, if you are having any technical difficulties, please click on the red live support button located on the top right-hand corner of your screen. I just wanted to acknowledge that it is Maori Language Week, as Michael mentioned in his welcome. And so we encourage you to do kōrero in te reo, or introduce yourself in te reo, or just say hello in te reo, which is kia ora, just to sort of acknowledge Maori Language Week and this beautiful national language of New Zealand. Now, before I sign off, does anyone have questions? If so, you can type them out in the Q&A box, which you will see on the right-hand side of your screen. I'll wait for a minute or so just to give people a chance to type it in. I don't see anything at the moment. And yep, nothing right now. So maybe I'll, we'll see if there are questions coming through later on. But thank you for your attention, and I hope you enjoy the conference program and the opportunity to network with your peers. Make yourselves comfortable, grab a beverage. We will start the conference with our first keynote by Dr. Aleksandra Pawlik at 10 a.m. See you there shortly.
Okay, I think we can start. Okay, Tena Koto Katoa. My name is Wolfgang Hayek, and I'm an HPC research software engineer at NIWA in Wellington. I also have the great pleasure of chairing the first session of this conference, which is the keynote session. So before we start, a little bit of housekeeping. At the bottom of your screen, you'll find a live Q&A button, and please use that to post any questions that you might have, and I will read them out after our speaker is finished. And as Nuria mentioned before, at the top right corner of your screen, you should find a live support button, I think it is called, that you can use if you need technical support. So the session will run until 11 a.m. and then we'll go into our first break. And now let me introduce you to our keynote speaker. So here's Aleksandra Pawlik. She is an e-research capability specialist at Manaki Whenua Landcare Research. For over 10 years, she has been working with researchers, helping them with the computational side of the research, from data management and analysis to improving their programming skills. She has helped develop software and data carpentry training across several countries and taught 60+ workshops, which has been a very rewarding experience for her. So please welcome Aleksandra. Aleksandra, over to you.
Public Aho. Thank you very much, Volker, for the introduction, and big thanks to everyone organizing this conference for putting together this event and inviting me to give this talk. I will talk about FAIR for research software, or as it is conveniently acronymed, FAIR for RS. You may see this acronym popping around if you investigate this topic. So first, perhaps it's worth to highlight a little bit what is research software. I don't necessarily want you to read the slide. There's a lot of text here. This is a screenshot from a paper authored by several researchers from institutions literally across the world, from both hemispheres and several continents, including also the tomorrow's keynote speaker, Daniel Katz. I do recommend his keynote tomorrow because I know it will be great. This paper is a discussion paper. It's not necessarily a paper based on empirical research, but all the authors of this paper have had a long-term engagement with research software and also research data. And the reason why I want to bring up this definition of research software, which actually is a discussion, and the authors say here, controversial discussion. I think controversial because there's so many different opinions, sometimes very strong, what is research software. And in my talk, I want to have this very broad perspective on it, something that the authors here of this paper, if you read the whole paper, also tend to adopt. Research software is not just a big suite of software developed by a community of scientists. So things like you might have heard about NumPy or SciPy libraries, or certain packages in R, or a particular suite of software for advanced astronomy research. That is definitely one of the categories of research software, but it goes way beyond that. It includes bits of scripts, even small scripts that people reuse and share. It also may include some proprietary software, although we tend to look at in this paper and also in what I will talk about, a lot of things pertain generally to open source software. But it is a very wide definition, and by that wide definition also means that it involves almost any researcher that is out there. I do work with a lot of researchers who say, "Oh, I don't code, so the whole software thing in research is not really my thing because I don't code. But then when you talk to them, it turns out, well, they do use some bits of some, for example, short scripts that some colleagues wrote, or they downloaded them from somewhere where they were released. And these pieces of software may even have graphical user interface, so there's no sort of command line engagement with it. And then you say, but you are pretty strongly connected to the research software, and the topic of fear is definitely something you should have awareness about. And then, of course, there's the whole group of people in a similar role like mine. Most of the authors of this paper have roles somewhat similar to mine, who support software and data in research, so often not necessarily doing their own research anymore or doing it in less extent. And for us, this is a core topic of making sure that research software, just like data, is fair. So what does this fairness, what is this fairness about? FAIR is an acronym, FAIR principles: findable, accessible, interoperable, and reusable. And originally, the FAIR principles were developed for research data, where there was this whole discussion around FAIR principles for data. But then it became quite obvious that fairness is also about research software, or probably even wider, we can say now, about research outputs, because research software can be one of the research outputs. So findability, accessibility, interoperability, and reusability of research data, same principles apply to research software. Findable, sounds self-explanatory, and it is. It's easy to find software and associated metadata, so information about that software. That might be documentation, but also things like license, things like authorship, perhaps examples of how to run it, sample data. It's easy to find for us humans, but also machines as well. And that findability, you can think of, probably immediately you think, oh, so Google can find it. That's one of the findability ways to find software, but it is also about software that might be available within your organization. So Google doesn't trawl your intranet or internal servers or storage, but you know the software is out there, or you hope that there is some software. And so how does the organization work with that storage and the systems available to make sure that you can find software or systems that support your intranet can find that software. Accessible software, and again the metadata, so that is a whole package, can be retrieved through standardized protocols. So probably the easiest example, think about, you use Google to find software or package. If you're, for example, an R programmer or maybe Python programmer that does a particular thing that helps you for example, do a particular analysis. In R, generally the standardized way, 2 or 3, but usually most R users expect packages to be available for the CRAN repositories. yeah, that's how they would hope that the package will be made available so they can install it. This is the standardized way of getting an R package. Sometimes packages that perhaps are not yet ready for the R, for the CRAN repository, there is something called DevTools. I'm just giving an example here if you're not familiar with R, but there's another way of, okay, your package is not in CRAN, but there's another way of installing it, which is a pretty standard way. And again, this is what people would expect. And of course, you can make that R package available differently. So somebody has to download the code, perhaps has to compile it, and you provide all the documentation. That's not to say that it's completely non-standard, but it is something that people are less familiar with. So that accessibility here is definitely lower. And yeah, the fairness of that software kind of scores a little bit lower. Interoperable. Software can connect with other piece of software, and that is done somewhat, maybe not seamlessly, but again, in a standardized, well-documented way. And this pertains to situations that you might have been familiar with, or you've seen where people come up with some amazing, incredibly fast, incredibly efficient ways of interaction of software interacting with a database or a data source or display, but it requires the users to pick up a lot of new skills, and perhaps can also require those other resources to make some changes. That is pretty low interoperability. What I'm trying to emphasize here is that coming up with the most amazing innovative solutions does not necessarily guarantee fairness. That's really worth to keep in mind. Reusable. That is, again, something that perhaps I expect quite a lot of people in the audience had poor experience with. So you can find the software, you can access, you can download it or install it or plug it in a pretty standard way, as you would expect. It seems to be able to connect to other services or interact with them, but actually you struggle to figure out how to make use of it, how to, for example, run a particular analysis, so the execution, or it does run, gives you some results, but you can't make sense of the results. Or you can make sense of the results, but it's not exactly what you'd like. You'd like to be able to modify it so that the results in a different format, or there is additional information that the software spits out. You have no idea how to do it because there is perhaps no documentation. Documentation is incomplete, or the way it is written and presented is incredibly confusing. That is a very frustrating situation, and it's unfortunately a common situation in research. There was this joke on Twitter. Well, somebody posted on Twitter saying it was a joke saying, "Here's the link to the software. You can download it, but good luck downloading the only postdoc that knows how to run it." And so, yeah, if there is only one person in the world that can get the software to run, that is a really poor fairness situation. Here again, a screenshot from a paper towards FAIR Principle for Research Software, written by several experienced authors in the area. This table here, which you can find in this paper, expands on these 4 principles: fairness, findability, accessibility, interoperability, and reusability. And it's a sort of a comparison. So the FAIR for data has been something that has been discussed and worked on for just a bit longer than FAIR for software. And so what the authors did, they took fairness for data. As you can see, for example, the FAIR principle, it's kind of divided into 4 sub-principles, F1, F2, F3, and F4. And they look at those sub-principles or these more detailed discussion, and they look how does this translate to software. A lot of it is pretty much identical. So for example, data are described with rich metadata, software is described with rich metadata. So in this case, it's mostly rephrased. But then some of the selected of those principles, they are a little bit expanded for software. So again, I recommend this paper, 2 years old, but yeah, still very relevant to have a look at. So what is being done around fairness for research software? One of the biggest efforts that is worth attention, also because it's a big international group, is FAIR for Research Software Working Group that has been formed within Research Data Alliance. Research Data Alliance, it's an international community formed organization that holds, not only has working group, but also holds regular meetings and workshops, conferences, originally formed to address challenges around data and research, hence the name, Research Data Alliance. But it is understood now that the word data perhaps kind of could be replaced with the Research Output Alliance, but historically it remained RDA. And one of the outputs is software. And hence it was a natural place to form a working group within the RDA. The working group is open. It's a community-driven effort, and the working group is open for anyone to join, and already has a number of members. A lot of them, or almost all of them, well, all the authors of the papers that I referred to are members and are active members within these communities. And there is discussion forum, but also this group has right now 3 main goals. Some of them are slowly shaping up. So the first one is to, actually this should be a swapped order here. So the first one is to define the FAIR principle for us research software and publish a document. This again is an area where there is a lot of discussion, and there's a word define or definition of FAIR principles. They're going to be pretty wide and evolving, and part of the goal that this group has is to start the discussion and get the collective feedback to see if the definitions are really fitting the reality. The second goal is to prepare a document with guidelines on how to apply fairness, FAIR principles for research software. So I have already covered a little bit what are the principles, and they seem self-explanatory. They are, it is, a lot of it is common sense. But how do we actually do it? If it was that easy, we would not have to have this working group, and we would probably not need this this presentation here. But yeah, there are problems, there are challenges with fairness for research software, and I hope that now, when I went through these principles, you perhaps were looking at them and going, "Oh yeah, that happened to me," or "I've heard about this." And the third goal that at the moment this working group is aiming for is have a documented examples of adopting the FAIR principles for research software. They generally come from organizations, projects, even sometimes research groups. The adoption of these principles can also happen at the individual level. But yeah, we want to see, it's good to see examples also in the context of how they were applied, to think, oh, this is perhaps what I could have done or what I could do. Beyond RDA working group, there are other projects, initiatives, organizations that are looking into supporting fairness principles and helping to implement them. This is all a connected network. So I talked about RDA first, but all these organizations here that I list, it's just a selection, that's the first thing, but also they are strongly involved within the RDA group. And these are shared resources to help researchers understand the principles and the importance of these principles. Apart from that, the goals of these different initiatives and organizations is to influence policymakers and help find resources for implementing fairness. Because you may say, well, this is all great, that the software needs to be findable and has metadata and is deposited in a registry. But the reality is we just don't have resources to do that. We simply to put that in many, many projects where software is part of the outputs, or there is some work with the research software. There is just not enough funding to make that software fair. I did mention that fairness of the software does apply to commercial software, proprietary software. In this case, perhaps funding is not so much of a challenge, but it does show that funding is not the only reason why software may not be fair. It's also probably the awareness. But when we look at software that is an output of work done in publicly funded research projects and organizations, the resources are pretty scarce. One of the main reasons is that you are aiming for a publication. Publish or perish is the key challenge. Well, the goal, but it also creates challenges. As soon as the paper is published or papers are published, you expect to move on to the next software, the project, or you already are working on the next project, or other outputs. Even though extremely important, do not necessarily contribute to progressing research science career. And therefore, it's hard to focus any resources on it. So part of what all these organizations are doing is to raise the awareness among funders and provide arguments and drivers so that you can receive funding to help you make your software fair. And also perhaps form organizations or projects that their main goal, and hence funding for them, is to sustain and make software fair so that researchers can carry on with their science. Because again, a lot of researchers just don't have the interest in working further on making software that they contributed to fair. This is not the goal for many researchers. They want to carry on with their science, but someone's got to do it, and we need to find ways of doing that. I do encourage you to listen to tomorrow's keynote, because I think Daniel Katz is going to talk a lot about sustaining research software and hence making that software more fair. The organizations here that are listed, this is not an exclusive list, this is just a selection that I picked that is worth looking at, and looking at some of their guidelines and also some practical tips on making software fair. Software Sustainability Institute is based in the UK, but they have a lot of international engagement. It's a project that is shared between 4 different universities, and it's been running since 2010. I used to work for Software Sustainability Institute before I arrived to Aotearoa. Yeah, a lot of information on that website, a lot of really useful practical tips. But again, Software Sustainability Institute has a great success in influencing policymakers. And it was actually at the Software Sustainability Institute where the whole idea of recognizing research software engineers and bringing up this name to publicly funded research to academia as a career path and as a position, that's where it originated. So a place worth getting your information from. Netherlands eScience Center, based, as the name suggests, in Netherlands. Also, several organizations exist like that in different countries, focusing on e-science, so digital side of science. I highlighted Netherlands eScience Center because several people there are very active in the area of sustainability of software, its fairness, and again, finding examples and providing tips. And something closer to our geographical area, Australian Research Data Commons launched several months ago, early this year, early 2022, Visible Research Software Interest Group. And this group focuses entirely on software challenges, but also solutions. And Paula Martinez, that is, she is also going to be giving a talk at the conference here. I do recommend looking at this group and also joining this group. This is open to anyone, and ARDC is doing some really good work in that area. And I hope this is going to spill out here into Aotearoa, and we will be able to also do some national efforts here, perhaps join with our Australian counterparts. And finally, Software Heritage. So Software Heritage is a project that was launched originally in France by INRIA, which is one of the French research organizations publicly funded. They have a little bit more focus on building a major archive for software in research, and that archive actually exists, and they you don't have to submit your software. They also harvest places where software is expected to be deposited, so places like GitHub or Bitbucket. But they do provide a lot of practical also information around what to do with your software to make it fair. So in their case, it's quite a lot of the findability aspect that they contribute to, but not only. And they they have been growing for the several years as well. So worth to look at their website as well and see what you can take out of this to make it work a bit more fair. Implementation, I already alluded a little bit to it. A few things to consider, also things to perhaps the things that have to be considered to make your software fair. You do want to have your software in repositories, preferably public and preferably with version control. There is a lot of often discussion at research organizations and projects about making software publicly available, open source, even before the project ends. There are voices saying, "Oh, somebody's going to steal my idea." To date, I am not aware of any evidence of that actually happening. Quite the contrary, there's a growing number of researchers who develop their software, put it out there in the open, and nobody steals their research idea. The reasons are multiple. One of them is if you already are at your idea is so well developed that you know where you're going with the software, it's a long way for somebody to just jump in and steal your idea and steal your software. So to date, as I say, I'm not aware of this actually happening, that somebody is going to steal the idea. I'm not talking about taking away the software and then trying to claim it's someone else's. But here, having software in a public repository with version control, this is actually where your protection comes in. If anybody tries to claim that they were first, you have good track record of this is what I have been developing, how I've been developing it, and this is you can see who has been contributing. Software license that is linked to what I just discussed. The license defines how the software can be used, by whom, reused. Also, can it be used for further sort of development, and you can specify that there are different licenses. You don't have to write your own. You can choose a license that says any derivatives from this software must be also open source. You can't take the software and build something that is going to become closed source if you are concerned about this. I do encourage permissiveness, as in allow anyone to use it for any purposes. That doesn't mean that you can't restrict anything derived from it. It still has to be open source. Software license is absolutely key, because by default, if you have your software out there in a public repository without the license, my understanding is, from the legal point of view, in most countries, it will be treated as the software is cannot be reused. So no license means no reusability allowed. Of course, it's publicly out there. You don't control that, but people may see it this way. You will lose out if they use the software to do some work, and then perhaps that helped them to keep working further and get some results, because they may be afraid to refer back to your software, or they feel like they can't, and so your software is not going to be recognized. And you want it to be recognized, and you want it to be referred to, because it is becoming more and more common that the research outputs are counted in different assessments for research careers. So in PBRF, software hopefully will become one of the things that count, not just the papers. You want to register your software in registries, catalogs, usually driven by the communities and projects. This will vary between projects, between communities, between research domains, but some domains have fantastic registries and catalogs where researchers know this is where I need to look for things that help me do my work. Software citation, this is a big topic, but there are these days guidelines around software citations, formats for software citations. This links back to what I said about you want your software to be recognized. So license and citation means that there's a high chance if somebody uses your software to cite it, to refer to it, it's going to go to the references, and you are able to say, look, this research output is very useful. This is how it's been used, and this funding has been incredibly productive. And with time, I do hope this has become a standard. It's going to become a standard. It's not just your papers and your citations that will count towards your career. It will also be the software and data for use. Metadata for the software. This, again, I mentioned a few times. This is, again, the whole package. So yeah, license, citation, this is part of the metadata, but documentation, examples, and the documentation also of the science behind the software. So models that might be implemented. All this is part of the metadata. And API and standards, this is about interoperability. So making sure that your software, if this is interoperable, this also is a part of make sure that it's not just one machine that the software runs. If it only runs on your laptop, then yeah, this is affecting reusability, but interoperability as well. And yeah, a lot of focus in fairness for the software is looking at the community. So what I talked about the RDA group and working group and a few other initiatives. A lot of what they do is getting feedback from the community and arranging workshops and getting the community to tell them, okay, this is how things are at the moment, and these are the reasons, so that if there are challenges, they can be addressed. There are existing practices around research software. An example here might be prevalent use of GitHub. So there are alternatives to GitHub, but GitHub is incredibly commonly used for research software. And so whilst there are voices about possibly this not being the best place to have all the research software, it is the place where most of it is. And so we need to accept that and build other practices, the best practice, or develop best practice of how to use GitHub so that it meets your software meets the fairness principles, but also find other, make sure that all the other things that we build around, they can be compatible with GitHub, because that's what the existing practice is. Another thing is surveying the community. So something that the Visible Research Software Group in Australia has been doing recently is a survey on how do you find your research software. And I'm really looking forward to seeing the results of it in very short time. Paula Martinez will talk about this a bit more. And finally, also helping to develop skills to researchers and research groups to make sure that they and that the researchers know how, not only are aware what fairness is, but have ability to implement these principles. Software carpentry is one of the good examples of helping people make software more fair in research. But there are lots of other initiatives and yeah, just bits and pieces of skills development. Thank you very much for your attention, and yeah, I'm looking forward to any questions.
Yeah, thank you very much, Aleksandra. That was a great talk. So a reminder for everyone, please use the live Q&A button at the bottom of the screen if you have any questions. And I can see one question from Raul and Mossbergen so far. So he asks, with software citation, do we want to reproduce the academic citation model, which would also reproduce its flaws? For example, citing someone is a political act.
Oh, good question. I hope that it may not be a political act. So actually, perhaps there is an advantage in software citation that you would hope that software is cited because it's been used to some extent in the work done. I can't imagine a situation where software is cited as a it wasn't used, but it's it needs to be referred to. But I think that may be a bit less of a common occurrence, that there's going to be this prompt if you used it at any stage of your research, you want to cite it. I hope that it wouldn't become, it wouldn't have that flaw included. And there is a lot of work done around software citation. I didn't reference it here because I think it would be, it is worth a separate talk. And talks like these have been done, so you can find both recordings and slides and something worth investigating around software citation and their interest groups and other efforts. And so most of them focus on the format. So how to cite software, because software evolves. So it's quite different than a paper that generally has a final form. Although we do see nowadays papers that get revised, but that doesn't probably happen as fast as with software, or may not have as much of an impact on the paper. Well, software does evolve and there are releases, and but they're not always marked. So there's a lot of discussion about how to cite software. There are software citation models, quite mature, and I do encourage looking into them using them. But yeah, the question I've never thought about this, that yeah, citing software, just like citing papers, the political thing. So we should cite this, otherwise the reviewers are going to say, oh, you forgot to cite this and this work, even though it's perhaps not that relevant. But yeah, my hope is that due to the nature of what software is, perhaps we might be able to avoid some of those flaws.
Yeah, I mean, I guess that it will probably have to evolve, right? So, I used to work in astrophysics, and it was common practice for people to publish software in a paper, and then that paper would be cited henceforth as kind of the reference. So, if you used someone's software, then you would just keep on citing the same paper. But sure, it does come with all the flaws of the citation model, but also the recognition, right? So, I mean, so if you publish software, then you get the recognition and potentially can show that to decision makers, funders, and so forth, and saying like, here it's worthwhile doing because that paper attracted a lot of recognition.
Absolutely, yes, and this is a really important thing that you mentioned, Wolfgang, that because I talk about different citation models. It's not a completely new thing. So there are domains in which it has been a long-standing thing that a paper about software can be published, and then this is the citation for the software, which is great, and that is something that could always become almost, ideally that would be a standard across domains. But there are some domains where, unfortunately, due to how flawed the system is, it's hard to publish a paper about software, although there are now at least 2 or 3 venues. One of them is Journal of Open Research Software, And if you look at Software Sustainability Institute website, there will be information about this. So that's where you can publish your software, a paper about your software, and that becomes an easier way to cite things because it's a paper to cite. But unfortunately, because of what software is and how the academic system is geared up, it's not always easy to publish a paper about software. And so that's why that work of in finding models for citing software as a well, that doesn't have a paper started. But yeah, it's a really important to acknowledge that there are communities that have managed to deal with it really nicely already.
So I saw that Roland posted a link to an article, I think, about software citations, and notes that people in an institution would use the software built in that institution to help the institution, even if it is not the best solution. Yeah, I think I would expect such an effect as well, right? I mean, in parts, I guess it's because you might know the person who wrote the software, and then it's easier because you can just go to the office next door and talk to them if you have a problem, rather than having to resort to email discussions or online forums.
Yeah, I think this is a really good point that, yes, it might be because the people want to help the organization, but I think what also happens is indeed it's the colleague next door or at the next desk, or you might be joining a project where the software had been used before, and yeah, it's simply so much easier to have someone to talk you through it than you have that email exchange or forum, or sometimes unfortunately there's almost nothing.
So what do you think the current landscape looks like when you look around? So how much of the software that you see follows the FAIR principles? I mean, when I look at the different principles that you explained before, it seems to me that some boxes are easier to tick than others. So I mean, making the software findable, I think, is doesn't really require much, for as long as you have a license that's permissive enough. But things like interoperability or reusability, that's something that can be quite difficult to achieve, because often you would need to take that into the design consideration from the start. And so when I write software for others in my job, I often find that I start writing the software, and then when I start explaining it to someone else, I realize, oh, okay, that doesn't actually make any sense. That made sense to me at the time, but then I go and have to take some time to change the design again to make it a little bit more intuitive or understandable. So what I'm trying to say is it does come with a lot of overhead, and so I suspect that it's very difficult, as you said before as well, for people to tick all these boxes. So how what do you see in the landscapes? How far can people go with it?
Very good question. So sometimes I feel like the landscape is changing, but I feel a bit like I maybe am quite in a bubble of a lot of people that preaching to the choir, and everybody's like, yes, and we have all these things that are happening, and it's true. There is a lot of work to be done. I think one of what you said shows this is one of the key things where you said, oh, I need to go back and rewrite the software. The good thing is, well, I know you have to balance it, but your job is to make that software fair or close to fair. And we need more of these jobs, and we need to recognize this as a pathway in research. So research software engineers are people who are helping to make software fair. And yeah, that burden will probably, the responsibility is something that it needs to be shared between both researchers and research software engineers, which is that should become, and it is becoming, a pathway in a career pathway. It's again something that comes back to funding for making software fair, and so making it creating enough space, mental space, which just really belongs to, depends on funding and enough resources. I think the example that I bring in, which perhaps maybe is not the best, but now we all write our publications pretty much ourselves. Word documents can be beautifully formatted. You can print out your own, beautifully formatted document. You may need to pick up a few skills, but generally, it's not that difficult. But it's not always been like this. 30 years ago, even maybe 40 years ago, a lot of organizations, including the one that I work for, had people whose job was to format the reports, and so sort of typesetting people. Nobody questioned this kind of overhead that was absolutely needed, because otherwise it would be really difficult to read for these reports. They would be really terribly formatted, because we didn't have support of autocorrect, of spelling checkers, and all this beautifully easy to point and click formatting things. And yeah, perhaps this evolution, these jobs, most of them diminished or evolved a bit, but yeah, you can put together a nice report yourself. You really generally don't need anyone to help you with that. But yeah, that what changed is you are producing some software as a researcher, and perhaps this is what we not perhaps, but this is who you need. You need research software engineers and another area of support, and yeah, and I think that's what's this battle with the funders or the policy makers is going about. And it's not that jobs disappear and because things become automated. There are new jobs that emerge because things became automated or some technologies developed.
So Hilary Oliver posted a question asking, is there any place for proprietary software used in generating published scientific results? What do you think?
Of course, and we see things like one of the big examples is MATLAB, which is used a lot, and for good reasons. It has things that researchers find really useful. Although you could argue that perhaps the equivalents are equally good, and it's just a matter of switching. But in the GIS and spatial communities, ArcGIS proprietary software is dominating. And yeah, in an ideal world, we would like all the publicly funded work to be done with freely available software and open source software. And that's what we would like to strive towards, and that's the skills development. But in my opinion, we also need to look a little bit of pragmatically, and in particular, if the community is embedded or is using a particular piece of software, then yeah, it's let's work with this proprietary software. Let's work with this and make a gradual change, or hopefully, and this is what I generally see. I'm not a GIS expert or GIS. These providers, the commercial providers, they understand that they need to provide ways of their software to be interoperable, so people can develop open source tools that connect with them. And so that is, I'd say, I guess there is space for that, as long as you're not completely locked in that software, as long as you can somehow gradually translate to open source.
Yeah, it seems to me the air is getting a bit thinner these days for for codes that are not open source. So so as Hilary notes here, it impacts scientific reproducibility if you don't have a license. And I'm working with a closed source code a lot, and they are getting more and more under fire for being closed source. Where if you make publications with it, then people request, sorry, we cannot. Or they request the source code and tell you like, sorry, we cannot accept this publication if you do not make a code available. Even if it's maybe just more a gesture than people actually going and really using the code, but nonetheless.
Yeah. Some sticks are needed, not just carrots, and yeah. But I do know from experience that forcing people into things usually backfires. So there needs to be a bit of a smoother transition.
So Shane Starrock asks, a challenge for software is allowing it to continue to run in the future. Compiling code from even 15 years ago or even running it is a challenge, especially with commercial software. Or it's more a comment, I think, than a question.
So is using legacy software that has been developed a long time ago. Yeah, I guess that's a fair comment. And yeah, part of it is that the software probably originally wasn't very fair, and the longer time passes from when the software was developed, the less likely it is you're going to find someone that can help you with it. But also technologies change. You know, the version of compilers, but version of languages. It's a common issue I see. I work mostly these days with R users, and there are things that were developed 4 years ago, small package, but it's not maintained. It's very good package. It does the job. It's it's correct. It's correct results. We know how to use it, but unfortunately, the new versions of R or new versions of libraries that it depends on are not backwards compatible, even though this is always taken into account. And it's there's a lot of work around to make it work. I think this will always somewhat be a problem because I'd say in a way some of these packages are fair. They're just not being maintained to be compatible with new versions of R. However, if you try to run it in a lower version of R, they still run fine. So yeah, that's always going to be a challenge, but it doesn't necessarily mean that the software isn't fair, close to fair.
Yeah, but I think we all know that situation that you get asked for help, and so someone comes with a piece of software that's 20 years old, and like, there was this person who wrote it back in 1999, and we need this now. Can you please get this to work? Like, okay, so a quick sigh, and then a deep breath, and you hope that the whole thing works, right? So yeah, it's quite a common scenario, I think, and this will keep following us around. Even software that is well maintained, if you don't keep maintaining it, you'll always have that situation after 10 years, 20 years or so, that people are long gone who wrote it, and you need to get very creative to get this to work. So Shane asked the second question. He says, shouldn't papers include a containerized version of software they used to at least give it the best chance to run in the future?
It is sometimes a requirement. Wolfgang actually did mention this, that with data, it is becoming almost a standard that lots of journals say you will be accepted. This will be accepted for publication only after you deposit data in one of the following repositories or make it available. We can also make it available from a repository that the organization runs. But anyways, it has to meet certain standards where the data is. And this is becoming, it happens with software. They want to see at least the source code. And yes, ideally container, so it would be easy to rerun. I think the challenge is here, again, building skills, because one of the authors is somebody helping the others would need to help with containerization. And again, this is the research software engineers who can come in and say, okay, I'll containerize this for you. So these are the jobs, the career pathway that is helping with that.
Okay, great. Thanks, Aleksandra. So we're pretty much at the end of the time now. I saw that in the discussion forum, there's now quite a long discussion about the ins and outs of citing software. So please keep on discussing. We're now heading into our first morning tea break, and the next session will begin at 11:20. And thanks so much again, Aleksandra, for a great talk and a great discussion.
Thanks, everyone, for a great discussion. Thank you for cheering Wolfgang. Yeah, and see you, everyone, at the subsequent sessions.